Okay, and here's a link to the agenda for today. And like Brian just discussed, we'll move the first agenda item down. Yeah, so I think the next thing was the Zygote PR. Let me copy the link to that. Oh, thanks, Brian. Right. So Michael isn't here, but I think we can probably figure out what we want to do on this. Um, yeah, I mean, the basic gist is if you have a function that returns more than one output, um, should we have with gradient, which normally returns the output, and the gradient give you all of the outputs plus the gradient with respect to the first output. Brian, did you have anything specific about this that you want to discuss?
Nothing specific. I was curious to hear your thoughts about your last comment you posted there about the Switch. So I am of a similar opinion. Um, my only question would be if we have a switch or a flag or some other way of signaling this, can it be made type stable?
Hmm. I guess what would be the expected behavior if that flag was false? Because, I mean, if you have a tuple, what if I don't know what the definition of the gradient would be with that flag false anyways. Um, like I don't know why Jax chooses to have the flag. Is it like a semantic reason? Um, to just make sure that the user has control over this, or is it something to do internally with how they trace in order to do the gradient transform? You get what I'm saying?
I'm not sure. I think they presume maybe they make the same assumption that we do, that the return value is some scalar, and then this helps them thread through auxiliary data because their API is even more functional than the one we have for Zygo. That would be my guess. Because they say it returns a pair where the first element is considered the output of the mathematical function to be differentiated, and the second element is auxiliary data.
Right. Yeah, I'm trying to read the other keywords and see if there's like a case where the second element would mean something for what's being differentiated and not just auxiliary data.
I haven't read through this section fully yet, but there is this link in their tutorial which has a function which returns a tuple, and they talk about using the hasaux flag to differentiate through that function. What I'm not sure yet is this a purely pedagogical example, or are they trying to advertise the feature here? Link is in the chat. Sorry.
Yeah, I'm reading through the link. Sorry, that's why I haven't responded yet. Yeah. Um. Yeah, I mean, just at least from what's in their docs, limited amount that's there. I don't know if there's something in the developer notes section. Um. Okay. Yeah, I mean, I guess if you think about it from the perspective of pullback, you could have multiple sensitivities.
Yeah. The question. So currently we don't. The question is, would we ever consider supporting tuples as like creating multiple sensitivities for multiple return values? We can do it, like, but do we for gradient specifically, we can do it, but do we plan on or do we anticipate ever doing that?
I mean, I feel like, yeah, so I guess I'm fine with the change that Michael's suggesting, and I'm leaning towards not having a flag to control it and just doing it, because that use case that you just mentioned, I feel like we would just use a different name for that function. Like it seems wrong to me to call that a gradient. I think gradient kind of implicitly is assuming a very specific thing about your output. And so it's not super magical to me for us to interpret additional outputs in this way.
Okay. So I guess
Yeah.
keep the default then. Yeah. Sure.
Yeah. I mean, I have no problem including the switch either, really. If we want to be conservative, like, I guess it always helps to be conservative. Yeah, I mean, I guess where do you land? Like, are you either or you feel strongly that?
I don't feel particularly strongly either way.
Okay.
And I think I'm mostly convinced by the argument that this makes sense as a default. The switch does seem like The jack switch does feel a little awkward, which was my main concern with that flag having the flag that way. And I thought about when they said pair, I thought about briefly, okay, why not return a pair like an actual Julia pair? But that doesn't really seem to be in the spirit of having multiple return values. Like the Julia has a native way of returning multiple values, and it's a tuple.
Right.
Um, so
Yeah, and I don't think that would match the semantics of how pair is used either in
yeah,
Julia.
for sure.
Okay.
Yeah,
So I think I'll comment and just add that we discussed this. The note about looking at it as multiple sensitivities, but we feel that for gradient, the interpretation of the PR is probably the good default one.
hmm and one thing we could consider is taking this even further and making gradient work the same way. So if you look on the Jack side, their grad, which is our gradient, also has the Hazox. Well, actually, that's the link you posted, and it can return. Um, it'll return the auxiliary data alongside the gradient. So that's something we might want to consider as well. It'd be nice to. I like the consistency between the two. I'm not sure if it might be a little riskier to have this on gradient. Can't think of any reason why it would be right now, but yeah, we can talk about that on the PR side as
PR.
well. See what Michael feels about that.
Okay. Yeah. I'll add all that in the comment.
Great, thanks.
Cool. All right. I guess the next thing was Julian. Um, you mentioned you wanted to discuss just distributed parallel stuff related to Flux in general. Um, is there something specific? I'll let you take it away. I see you unmuted. If you're speaking, we can't hear you.
Okay. Is this better?
Yeah.
Okay. Sorry, I guess my headphones don't work. Okay. So the main, I guess I'm just kind of checking in to see about, well, okay. So in terms of distributed training, which I guess is kind of the focus of what I'm interested in, or in discussing at least, I'm wondering if we've had any developments in like what's available for that other than Flux MPI, or if that's basically the current state of the art for us. And the reason why I'm asking is that obviously it would be great to have really good support for like multi GPU, multi node distributed computing, or distributed training, excuse me. And I would, I would hope that I could help out, by using Dagger and stuff like that to improve that situation. So yeah, is Flux MPI really like the only thing we have right now? Is that what we're recommending to users?
I think so. I don't
Yeah, I
know of
mean,
anything else. Yeah.
yeah,
Okay.
I think there's a couple like things that have been thrown up there, but not really maintained. And I don't know that we really recommend anything to users at this stage, at least not in the docs, I don't think. But if someone were to ask about data parallel training, that's where I would send them. That's the only package that I would be comfortable sending them to because I know it's being used by users and probably doesn't have bugs from bitrot.
Yeah, and even then, I remember is it Avak mentioning that there were some troubles they had with certain CUDA or MPI implementations, which made GPU training less. They had to do some workarounds, which made distributed training on GPU less efficient than it probably could have been. So it is still not a like a perfect drop-in solution, the same way you could have with like Torch DDP. One development which might be relevant is that Tim Bassar resurrected the JLs for Nickel for the NVIDIA communications library. That's only one vendor, but that's, I presume, enough if some high-level wrapper was either resuscitated or redesigned to get us data parallel and maybe even model parallel, pipeline parallel on the same node. I don't know if it would do a cross node communication, but it would be a start.
Yeah, I'm just, I mean, I guess Nickel can work fine for, obviously users of GPUs. I'm just thinking like, kind of going a little bit further. I mean, I know AMD has an alternative, but not exactly my point. I think I'm looking at, is there a way to make distributed multi-GPU training work generically on kind of, basically any configuration? And yeah, so I guess, so in terms of what we've built previously with Dagger, because obviously that's the direction I'd want to go with this. We have Dagger Flux, which is kind of layer parallelism. We can, if you have a model which has parallel layers, then you can kind of parallelize along that. And that isn't really great because, of course, not all models have parallelism in their layers, across their layers, sorry. So the alternative would be, and I think Dari and I were working on this, well, mostly he was working on this, was doing batch parallelism, which I think he was doing manually, just multi-GPU single node. And we were discussing doing a multi-node approach by using Dagger, but we never got there. I assume he probably got busy with other things. But I feel like it would be great to resurrect that, because it would be, I think batch parallelism probably works well for most models, and should be something we can do reasonably easily with Dagger. I don't know. I guess the area where I get stuck is that I don't really know anything about automatic differentiation. I see people implementing like pullbacks or derivatives or whatever you call it. I don't even know the terminology, but I see these things and I don't actually understand how to write them myself, nor how to handle them when they're also going through Dagger, and that's an extra layer of complication. But I understand how to expose parallelism. I know how, if someone is helping, like, okay, here, this data is mutable, we're going to have to operate on this in place, or like, here's an area where we could exploit parallelism. I can help with that, and I want to be able to do that. But it's not something I on my own know how to do. So I guess I'm wondering, is anyone interested in this? Would someone want to work on this with me? And also, maybe, do we know where Daria's previous work was? It would be great to resurrect that. I mean, if not, we could work from scratch, but
I think the last question might be the quickest. So I don't know. I know he had a repository where he was doing some work with just purely CPU. All the communication was done CPU side. I don't know if that's the one you're referring to, but I don't recall seeing any activity there in maybe a year or something like that, at least.
Yeah, I think the name of that repo, let me see if I can find it, was ResNet ImageNet.
yeah.
But he changed the name several times, and I've lost track of what it's called now. At least ResNet ImageNet produces nothing with a GitHub
Okay.
search.
I think it was
It-
renamed to like Flex Distributed, or I don't
Yeah.
yeah.
Yeah,
but
ResNet ImageNet redirects there to Flux Distributed, but it hasn't been touched in at least a year.
Okay.
okay. Yeah, but like Brian mentioned, I think that kind of piece of code has been around for quite a long time. And when he initially wrote it, I think the main point was the one Brian just brought up, which is that the cross GPU communication happens through the CPU. And that's why Brian, brought up nickel and whatnot, because really that's the piece that we've always been missing in Julia is doing like these all reduce operations across the different GPUs that we're parallelizing across, without having to communicate everything back to the CPU.
And so, okay, so I'm starting. Some of this is coming back. So to that point, I guess the main complication is, is the main bottleneck that we'd want nickel for. Is it a reduction step essentially? Like the all reduce, I imagine, is basically we're taking all of these results, we're reducing them across all of the nodes so that all of the nodes then get the same reduction result efficiently. Is that correct?
Yeah, like you were asking specifically about AD, every node is doing the full forward pass of the model independently, doing a backward pass on the batch of data that node has, and it gets the gradients for that batch of data, and that's where the all reduce comes into play, is reducing, summing the gradients across each node so that now every node has that total gradient, and then each node independently updates its parameters based on that reduced gradient. So that's where the cross-device communication is. And so it comes actually after the AD. So I don't think you will have weird interactions between AD and Dagger. But I also am not an expert on Dagger. So maybe that's where we can actually get into the weeds and figure it out if we need to.
I think part of the complication comes from depending on what kind of distributed training we're targeting. So even within the varieties which require these, which operate like batch or data parallel, you have varieties. So like PyTorch DDP, which is what most people use, does stuff like interleaving. I think they interleave AD and synchronization, so they actually run parallel, which is its own nightmare. They do stuff like bucketing, gradients, to amortize some of the communication overhead. And there's a lot of like engineering that goes in there that's quite invasive at the framework level. That like I feel like that's, if we did something for this, it would not be part of some MVP, but we would want to do it eventually to be performance competitive, and that makes my head hurt. So that's part of it. Another model that people are using a lot now is PyTorch fully sharded data parallel. Both the links are in chat. And that has its own model. So I think it might be easiest to start with exactly the kind of canonical data parallel model Kyle was talking about. But if we try to go beyond there to become performance competitive, then there will be a lot of considerations around like the type. I have a feeling the coupling might end up being tighter, just because existing frameworks kind of rely on, the distributed part communicating with the AD part, communicating with the memory allocator, and all of that.
Yeah, that's fair. Yeah, the like cross integration between all these different parts gets complicated. So actually, I think that is part of the reason why I think trying to attack this from the Dagger side makes a lot of sense, because if we basically have a way to say, okay, here's a model, here's some data. We're not going to do any pre-processing on this other than what you normally do to just do standard single GPU execution, and just hand that to some package which is using Dagger and let that package figure out the details so that we don't need to do a bunch of stuff in Flux to make this happen and have to make a bunch of changes everywhere to support this, and instead let this be a transformation that happens outside of Flux. And in Dagger, I think that would be a good approach, because taking a look at fully sharded, I'm mostly just looking at the image diagram of this. But I guess the point is you kind of have this pipelining that you want to do where data feeds into this at certain points, and you have separate sets of weights between your parallel between your GPUs or whatever it is, and then you're kind of at certain points. Is it synchronous gather and scatter, or is it or are these I guess I'm just kind of trying to understand where the parallelism is and where we have the ability to expose as much as possible.
I think across workers they operate in lockstep, but maybe some operations are interleaved within each worker. So like communication and processing. Because because the synchronization, the all gathers are synchronous. I don't think you can get in a non-deterministic state by running those. But as they say, the communication and processing are overlapped. So I think what was it? The moment you materialize a gradient, for example, during the backwards pass, you can, for a given parameter, the final gradient for a given parameter, you can shoot that off. You can start synchronizing that and then keep working backwards through the chain, right? You don't have to wait until you've gotten it all the way back through to send over all the gradients at once. So I would have to reread the distributed data parallel paper, because I think that's where most of the meat of this stuff is. But that's what I recall.
Okay, so you're saying essentially layer by layer, as you get to the end of the forward evaluation, and then you're kind of working your way backwards, you can start just emitting and transferring gradients the moment you have them. Is that right?
Yeah, I think in theory that's how they do it. I'm sure they have some heuristics around when to do it and when not to do it, and for DDP specifically, they have this configurable bucket size where they put gradients into this communication buffer until it's filled up, and then they synchronize that buffer, and rinse and repeat kind of thing. So just to reduce the communication, I guess not the amount of data communicated, but the amount of communication operations in flight.
Right. Okay. So I guess this kind of, and I'm guessing you can still combine this with batch parallelism in a way, right? I mean, you're still.
This is batch or data parallel, yeah.
Okay. It just sounds like you also have a level of parallelization across layers too. You're not in the standard sense, but in the sense that compute and communication as you go layer to layer can happen concurrently.
Yeah.
Which is kind of layer parallel. And in a sense, we have to look into the layers and do some extra things to make that happen.
Yeah, it's an optimization on top of the normal just distributed data parallel. I think where the fully sharded data parallel differs is it also splits up some of the layers and optimizer states across the devices. I have familiarized myself with what that does, so maybe that's something to focus on later after the simpler data parallel is figured out. But that's another way to split it up, right? I think JAX people like to do this a lot because they run on TPUs and those have good interconnects. But where like you toss this parameter matrix and you split it up over like however many devices. That's its own can of worms. Another thing is, so we've been talking mostly about data parallel here. And I know you mentioned that Daggerflex was more focused on model parallel. Another approach that is used is pipeline parallel, which is more or less model parallel, but with smaller batches to try to increase the throughput. And that's been quite successful. I think PyTorch has something built in for it now. The main challenge I see with that is that nobody has figured out a great way to partition up models between different workers. So for data parallel, it's relatively easy, right? You just have a complete replica of the model on each worker. But for anything model parallel, whether that's traditional or pipeline, you need to introduce those breaks somewhere. I think for the PyTorch implementation, they just ask you to specify where they are. That might be a little more difficult for Flux because we're not, your program isn't just one big network. It's a just arbitrary Julia code, I guess. And that I think is part of what makes this whole project more difficult. Like if we limited to just known neural network layers, and that's relatively straightforward. Like you can, I think you already did this actually in Daggerflex. You create like a node for each layer. But if you start like saying, oh, we want to support, differential programming and differentiable programming, and people can do weird loops and create all sorts of random functions in their loss, then that does get a little bit trickier.
Yeah, that's a good point. So, that's my dog. So I guess I would love to be able to exploit all of these possibilities. My hope is that, so I think that this problem you're mentioning of, like having to make these decisions of like, okay, where do we, like, what do we make the batch size, or where do we split some of these things? How do we allocate and schedule stuff is all very much stuff that Dagger as a scheduler and resource allocator will be able to tackle. Not necessarily today, but in hopefully the near future. I've got some work that is pretty close to being able to merge, which is basically allowing Dagger to have programmable like analyses and decision making within the scheduler based on essentially user provided code. So like the user could add essentially some analyses to the scheduler that basically will determine, okay, like how are we going to split this up? Do we want to do just data parallel data parallelism? Do we want to do pipelining? Like it could basically make all of these decisions and adjust these decisions at runtime as it finds that a certain approach is working better than another approach, or a certain sizing is working better, because Dagger is very much a real-time learning scheduler. It's not a, configure everything ahead of time and hope it's a good configuration. It's like it'll figure out a good one over time. That's kind of the ethos of the scheduler. So my hope is that if we build this on top of Dagger, all of these complications that PyTorch and other libraries like JAX have had to deal with, we can work around by letting the scheduler figure them out based on, basically analyzing how well does this run in comparison to another configuration that we can test.
So I mean, that sounds great as a long-term goal, because that's definitely where all these libraries are headed. Like, at least for me, in terms of making parallelism easy, JAX is, I think, probably the best example of that. And they're definitely heading that direction in terms of automatically splitting the model and data across many devices and trying to figure out the sizing and stuff for you. So it'd be great if we're going in that direction. I think what would be good right now, since your original request is like, are there people who want to work on this with you? I think, in terms of the Flux team, at least definitely Brian and I are interested in this project. I think in general for Flux stuff though, any development at all is super asynchronous because none of us have full-time resources to dedicate to Flux. So I think that, at least for me, I won't speak for Brian, but at least for me, I'd be interested in helping. But yeah, the trick will be trying to figure out how to plan this out in a way where we don't, stall on progress for several months at a time, like has happened in the past. And but also at the same time, we're not, necessarily needing to dedicate hours, a particular day, because there might be actual work schedule and that conflicts with that. But yeah, like in terms of like, I think the way to do it would be maybe right now, there's some models in ResNet I can think of in a particular data sets where I know what the sizing should be, and we can write a script that would run that on a single GPU. And I think the first step would be getting like distributed data parallelism. Like that's the easiest kind of parallelism to get in this scenario. And if we could get that, that would be huge, I think, for the community. And then like once I have the script written, I can tell you specifically, I need to split along this axis of this array across this many nodes. I think it's easier to have a concrete discussion that way.
Okay. Yeah, if you want to point me to one of those models, that would be awesome. I think also I need to take a look at all three of the packages. So Flux MPI to see what works, and then Dagger Flux and Flux Distributed to see kind of where those need to grow. Obviously, the all reduce is going to be a complicated part of that. I still have to figure that out. But a good benefit is that I have a GSOC student this year who's working on Dagger MPI integration, picking up an existing PR where I kind of got MPI and Dagger working, and turning it into something more stable and functional that you can just you can run arbitrary Dagger DAGs on an MPI cluster, and it'll efficiently either tile them or do the required MPI calls, like reductions and broadcasts and stuff like that. And that's going well this year already. So I think that can kind of help support this work. I also am in the same position. I mean, I'm kind of handing off AMD GPU maintainership to people at AMD, so I have a little bit more time, but also for me as well, this year is very busy already. And I don't expect to make big progress on this in a short amount of time, but I just kind of wanted to get things turning and gauge interest. But I think I can probably plan to start pulling pieces together. And then once I have some stuff kind of working, at least on one or a limited number of models, then we can kind of see if we can, I can pull you all in a little bit more and be like, okay, well, how do we improve this? What is missing? And then, eventually if it starts working well, how do we transition from Flux MPI to this new approach? And how do we kind of present this to users? But I can take the initial parts of this. It'll be slow, but I'll get to it eventually. I just wanted to bring it up and kind of have some discussion on it. But this has been helpful for me as well.
Yeah, I think, so I already have a training script for the metalhead model that I'm thinking of. It just needs to be updated for the latest way we take gradients and stuff in Flux. So yeah, I mean, I can. I mean, it's like a short single Julia script for doing that training. I can grab it, update it, make sure it runs on a single GPU, and hand it off to you. And I think hopefully that also helps you get started in terms of having a good test case for as you figure out like what's working and what's not working with various libraries.
That would be awesome. Yeah. And hopefully it's something I can also make sure runs on AMD GPUs, because that's for the most part all I have locally. But I can test that out and see if that works or doesn't work. And so yeah, that sounds awesome. There was one last thing and I don't remember what it is. Oh, okay. Semi-related, but not related directly. Do we have anyone in the Flux machine learning ecosystem that is interested in like Julia IR compilation projects and like optimization stuff? We'll ask that first.
I think it's less a matter of interest and more a matter of time.
Yeah, I guess that's also part of it. Anyone with interest and also a little bit of free time.
Yeah, because I think if we're going with this distributed route, my personal feeling is that that's maybe higher priority. Like I know, well, you probably talked to Paul Berg, right, about his work on Coil.
Yeah, but I'm not going in the MLIR direction with this. I'm going actually for something a little bit simpler, which is our GPU memory usage issues, which will be problematic the moment we try to scale up with distributed or not. So yeah, I guess the point is like, I'd like to improve our support one way or another, whether in base Julia or within a separate package, to basically decrease the ballooning of GPU memory usage that we have in models with using standard vanilla Flux. Because kind of like the thing that we're missing is the ability of the compiler to look at Flux code, which is allocating GPU arrays, and then say, I can statically free these arrays before the next time the GC runs, because by that time it's too late. And I have some existing work which started doing this, but I don't necessarily have the time or compiler expertise to push this all the way through into something that fully works, but I have working code which can do this. And I have also some interest from Shuhei in improving Julia's escape analysis, which is what that work is built on. So mainly just someone who's like willing to work on this in their free time and kind of get it moving forward.
Yeah, I saw your repository for the what was it, the ML code optimizer, which was doing this.
Yeah.
Yeah. It's tricky, I think, in part because of how the AD works, because Zygo will create this big data structure, this nested, I guess, data structure of which contains all the intermediate parameters and gradients and buffers that it needs. And then the lifetime of those only ends basically at the very end of the callback call. So I can imagine analysis would be hard for those. But you could capture allocations made during the reverse pass, which are transient, which I guess is what you're targeting.
Yeah, I mean, so yeah, I'm targeting basically really any allocations, but specifically GPU Q array or rock array allocations. within either the forward or reverse pass, because both of them can be relevant. I imagine most of the forward pass stuff we need to hold on to for the purpose of taking gradients, but the moment that any of these arrays are not used, we'd ideally have an optimization which would then invoke their finalizers and subsequently free those arrays, or at least schedule the freeing on, the CUDA stream or HIP stream.
Yeah. I think that's part of where the AD maybe gets in the way, because so Zygo, taking gradients of Zygo right now is basically equivalent to in PyTorch using, I think they call it retain graph equals true. So you can call pullback multiple times. That's what lets you call pullback multiple times. But in PyTorch by default, as they walk backwards through the graph, they start tearing it apart. So that lets them free a lot of those buffers created in the forward pass that were used for gradients earlier than we could, because we have to keep them around, because who knows, someone might call pullback again, and then we still need those buffers around. So I think that's one part that makes it challenging. If we didn't change anything on the AD side, but at least you could capture allocations that were made and not stored in some data structure to use for the backwards pass.
Got you. I imagine most of this code is also pretty. Is there any, by the time Zygo is done and has the final code to actually be executed, is that code, at least for simpler models, is it static or is there dynamic dispatch?
Depends. So if there is any branching in the code being differentiated through, it'll result in dynamic dispatch on the Zycode side. We try very, very hard to make sure that there is none of that in Flux, or any of it is hidden behind our rules. But it's not perfect. Like any keyword argument, any function that takes keyword arguments is type unstable, because Zycode doesn't know how to deal with keyword arguments in a type stable way. So you will run into dynamic dispatch. I think for we're working towards making basically models with all that only use built-in layers and Flux completely type stable all the way through. So any you should not encounter any dynamic dispatch, except maybe what happens in internally in base, and that would make the analysis easier. The tricky part is still that it's literally called pullback, that data structure that Zygo creates to store everything that's needed for the reverse pass. The lifetime of that is a lot longer than maybe it should be. And because Zygo doesn't have any runtime per se, there's no way to kind of finalize it or free it early. It just sticks around until basically the final gradients are being returned.
Okay, but it's something that if things were type stable, it would be possible to at least see, okay, which parts of this structure are no longer accessed. And in other words, according to the compiler, the liveness or lifetime of those previously made allocations could be considered dead with a sufficiently strong analysis that knows, okay, at the end of this call, we're going to lose this access to the structure anyway. Only the GC will be able to see it. Because that's something we should still, maybe with some work to escape analysis and liveness analysis, we should still be able to see, okay, this is not going to be accessed. We can still finalize this right after the last time it's used. So anyway, okay, well, if there is anyone who, who has the expertise for this and is potentially interested, just let me know. I can provide some mentorship on this and, show how my currently written analysis works. But if not, that's fine. We can also, it might make sense to wait on Shuhei and people like that to kind of improve things in Julia's core compiler before we really try to tackle this, because right now there's at least one issue that's kind of blocking that ML code optimizer package from being able to do this. So
I think one thing that would help for both of these projects is we just keep an open channel of communication. So it doesn't matter if it's just a question or any sort of discussion or like, hey, like how does this work? It's asynchronous, but it's better than nothing, right? So that might help with pushing both of these along.
Yeah, and I don't have any deadlines on these. I'm just, basically just trying to keep it moving. Well, now that I realize that these meetings are announced on Zulip, then I will be able to pay attention to that and try to be here and check in.
They're all on the community calendar, so if you have that, they should pop up on there. Yeah.
Yeah, and other than a rare exception, I'll delete entries off the calendar if we cancel it for that week, and we try to cancel, several days earlier in order to give people a heads up. But also, if there's supposed to be a meeting, and you do want to discuss stuff, then posting that on Zulip will ensure that we don't cancel a meeting. Basically, canceling happens if there's a few days to go before the meeting, no one has suggested any agenda items, and there's nothing that Brian and I know we need to discuss. So then we might cancel unless there hasn't been a meeting in a while.
That makes sense. Okay, well, I will pay attention to that, and if I have anything to talk about, I'll just try to let people know early then.
Yeah, I mean, I think that stream in Zulip where we have the recurring meetings, having a topic there, discussing things related to this project would be the best place to keep that communication channel open as well, just because we won't lose messages on Zulip. And then also anyone who might be interested in helping out here can also see those messages.
Awesome. Okay, sounds good. Well, I will post there.
Awesome, thanks. So we're almost at the top of the hour, but I know, Ashwani, you had some stuff related to diff images you wanted to discuss. So I don't mind sticking around. Oh, we lost her. Okay, well, give it a couple seconds just to see if they come back. And if not, then yeah, thanks everyone. If we can take any last questions if there's anything else, otherwise we can end for today, unless Ashwani joins at the last minute here.
Yeah, Felipe, did you have anything you want to ask or comment on today?
Okay.
No problem.
Yeah, I mean, feel free to type in the chat if you did have something. Otherwise, it's totally okay to just listen in.
Yep, no problem.
All right. Yeah. Okay, Ashwani is back. Okay, they're still joining. Okay. Ashwani, can you hear us? If you're speaking, we can't hear you. Oh. Okay, we can hear you now.
Okay, okay. So mainly I wanted to start the conversation for working towards, I know you guys are doing work on Metalhead, and there are a couple of projects like computer vision 3D related project and diff images, but it seems okay. So I sort of feel that it's a bit scattered, but I know you guys are focusing your efforts on Metalhead, and Abhirat, I think like 2 days back released a new version with a lot more models. What I wanted to ask. Am I audible?
Your connection seems a little unstable. So, oh,
Maybe I guess we could try one more time, but if this doesn't work out, maybe we can just ask Ishwani to follow up on Zil for Slack, and then we can start that discussion there. Oh.
So am I audible?
you are, but sounds like your network connection might be weak. So,
Yeah.
if you can type the question in the chat, that might work better.
So actually, mainly the question that I had was, do we have something like detection related toolbox, like object detection toolbox? I know we have object detector, but have you worked on something like toolbox or segmentation sort of box? Something like that OpenM Lab has.
Other than object detector, I don't know of any other toolbox for Julia. I know that well, now Metalhead has a port of the UNet model that was in fastai.jl, but fastai.jl has had segmentation support for like a basic segmentation setup. But other than that, yeah, object detector is the only one that I know of.
So let's say we take so I have been mainly trying the package by name ONNX. I don't know much about it per se, but it often shows that it's still under development and it's still in the process of being fully developed. Is it usable for bringing the models that are available on the PyTorch side or TensorFlow that are mainly available on Hugging Face, let's say? So I'm not asking who will bring them or pointing out you guys should bring them or anything, but is it possible the current version of the package to bring those models here in Julia's side?
I only caught a bit of that. So I think there's two parts to this question. One is loading, correct me if I'm wrong, one is loading models in ONX format, and the other is loading models from Hugging Face. Oh, okay. I think we should just ask Ishwani to maybe follow up with us on Zulip, maybe just offline. It might be a little easier.
Yeah, I agree. Okay, let me stop the recording and then I'll post a message on Zulip. All right.
Sounds good.
Thanks, Brian. See you later.
Right. Yeah, thank you. Bye.